Welcome, fellow developers and IT enthusiasts. Have you ever felt limited by graphical interfaces when managing files? Or perhaps you've been curious about the true power that lies beneath the surface of your Linux system? Today, we're diving deep into the core of Linux file and directory management, unlocking the efficiency and control that only the command line can offer. We'll explore fundamental commands that empower you to create, rename, move, and delete files and directories with precision and speed. Think of this as your hands-on guide to becoming a command line maestro, essential for everything from scripting automated tasks to efficiently navigating server environments. By the end of this tutorial, you'll not only understand these commands but also appreciate how they streamline your workflow, making you a more effective and confident Linux user. We even have a companion code project that perfectly complements this video, allowing you to follow along and practice every command we demonstrate. Before we unleash the power of these commands, let's set the stage. When you open your terminal, you're interacting directly with the Linux shell. It's a text-based interface where every command you type is executed. A crucial concept here is your current working directory, essentially, where you are in the file system hierarchy. You can always find your bearings by typing pwd, which stands for Print Working Directory. For this demonstration, and to keep things neat, we're going to create a dedicated space called demo_area. This ensures all our operations are isolated and easily cleaned up. We'll use the mkdir p command, where p creates any necessary parent directories, followed by cd demo_area to step right into our new workspace. This organized approach is a best practice for any serious command line work, preventing accidental changes to important files elsewhere on your system. Let's kick things off by creating some files. The command for this is touch. Now, touch has a primary purpose: to create new, empty files. Imagine it like laying down blank pieces of paper, ready for content. But it also has a secondary, powerful use. If a file already exists, touch simply updates its last access and modification times without altering its content. This is incredibly useful for triggering build systems or processes that depend on file timestamps. For our demo, we'll create a few empty files: document.txt, report.txt, and notes.md. After running the command, we can immediately verify their creation using lsl, which provides a long listing, showing details like file permissions, ownership, size, and of course, the file names themselves. This instant feedback loop is one of the joys of working in the terminal. Just as we create individual files, we often need containers for them. This is where mkdir, or make directory, comes into play. Directories, or folders as they're commonly known, are fundamental to organizing your file system. With mkdir, you can create multiple directories at once, like projects, data, and archive. But what if you need to create a directory within another, and the parent directory doesn't exist yet? That's where the p option comes in handy, allowing you to create nested directories like projects/my_project in a single command, automatically creating projects if it doesn't already exist. After creating these, using lsf will visually distinguish directories by appending a /, while a more powerful tool like tree, if installed, or lsr will beautifully illustrate the hierarchical structure we've built, giving you a clear mental map of your file system. Now that we have files and directories, let's learn how to duplicate them. The cp command, short for copy, is your go-to. It's incredibly versatile. First, you can copy a file and give the copy a completely new name in the same directory, or copy it to a different directory while changing its name. For instance, cp document.txt data/document_copy.txt copies document.txt into the data directory and renames it to document_copy.txt. Alternatively, you can copy a file to an existing directory, keeping its original name, simply by specifying the directory as the destination, like cp report.txt archive/. The lsl command targeted at the destination directory, such as lsl data/ or lsl archive/, will quickly confirm that your files have been successfully duplicated in their new locations, leaving the originals untouched. While copying individual files is straightforward, copying entire directories, especially those containing other files and subdirectories, requires a special flag with cp. This is where the recursive option, r, becomes indispensable. When you use cp, our source_directory destination_directory, Linux will not only copy the specified source directory but also all its contents, every file and every subdirectory within it, recursively. Imagine copying an entire project folder with all its source code, assets, and documentation. For example, we'll demonstrate by first creating a small file structure inside project/my_project and then running cp, our project/my_project/my_project_backup. This creates an exact duplicate, preserving the entire nested structure. Using ls, r on both the original and the copy will clearly show that the hierarchical integrity has been maintained, providing you with a complete and independent backup or working copy of your project. Beyond copying, we often need to move files or change their names. This is the domain of the mv command, which stands for move. What makes mv unique is its dual functionality. It can both move a file to a new location and rename it, depending on the destination you provide. If the destination is a new filename in the same directory, mv acts as a renamer. For example, mv notes.md read_me.md will simply change the name of notes.md to read_me.md. If the destination is a different directory, mv moves the file. So, mv report.txt project/my_project/ will relocate report.txt from the current directory into the project/my_project/ folder. This operation is atomic, meaning the file is either fully moved or not at all, ensuring data integrity. A quick ls, l on both the source and destination paths will verify these changes, showing the file disappearing from its old spot and appearing in its new one. Just as mv works for files, it operates identically for directories, allowing you to move or rename entire folders. This consistency is one of Linux's elegant design principles. To rename a directory, you simply specify its current name and the desired new name, much like renaming a file. For instance, mv data important_data will instantly change the name of your data directory to important_data, without affecting its contents. Similarly, to move a directory and all its contents to a new location, you provide the source directory and the target directory. If the target is an existing directory, the source directory will be placed inside it. For example, mv archive important_data/ will move the entire archive directory and everything within it into the newly renamed important_data directory. Using ls-f again will highlight these structural changes, letting you visually confirm the new organization of your directories and their contained elements. Now, for the final command in our core set, deleting. The rm command, short for remove, is used to delete files. It's straightforward, rm filename. However, it comes with a significant warning. Unlike dragging items to a trash bin in a graphical interface, rm deletes files permanently. There's no undo, no recovery from a recycle bin, unless you have specific backup solutions in place. For our demo, we'll cautiously delete document.txt using rm_document.txt. Immediately after, running ls, l and observing the file list will confirm that document.txt is no longer present. Always double-check your file names and paths before executing rm to avoid unintended data loss, as this command is a powerful tool that demands respect and careful handling. Deleting directories requires a bit more nuance. For empty directories, you can use mkdir. It's a safer command than rm for directories because it will only remove a directory if it's completely empty. If there are any files or subdirectories inside, mkdir will refuse to delete it, providing an error, thus preventing accidental data loss. We can demonstrate this by creating a temp_empty_dir and then successfully deleting it with mkdir temp_empty_dir. However, for non-empty directories, you must use rm with the recursive option, r. This command, rm, our directory_name, will delete the directory and all its contents, including subdirectories and files within them. This is the more powerful, and thus more dangerous, option. For example, rm, our project/my_project_backup will wipe out that entire backup copy we made earlier. Remember the ultimate caution, rm, rf, force recursive, should only be used when you are absolutely certain, as it bypasses confirmations and forcefully removes everything. Use it sparingly and with extreme care. So far, we've executed commands one by one. But what if you have a complex file structure to set up repeatedly, or a series of operations you need to perform regularly? This is where the true power of Linux shines through, shell scripting. Shell scripts allow you to automate sequences of commands, turning hours of manual work into seconds of execution. Our companion project includes scripts /create_complex_structure.sh, a